All right, guys, so we are going to jump into a new topic, and that topic is volume. And so up until now, we've been really focusing on 2D shapes. Now, 2D stands for two-dimensional. And you might not know that a dimension is something that you can measure. So 2D shapes have two parts that you can measure, two dimensions. That would be a length and a width. So if you take a look at this rectangle, this two-dimensional shape, you can see there's two things that we can measure about it. We can measure the length and the width. Well, we're going to jump into three-dimensional shapes today. Three-dimensional shapes have three dimensions, three parts that you can measure. They also have a length and a width, but now we're also going to add our third dimension, which is our height. So I'll show you an example here of what a three-dimensional shape looks like. We have a rectangular prism. Now with that height that you can see with that third dimension, 3D shapes take up space where 2D shapes are flat. Now, what we're going to be focusing on this week is a different thing that you can measure about 2D and 3D shapes. With a two-dimensional shape, if you want to measure the space inside of a 2D shape, the space inside is called the area. So if you take a look at this rectangle, let's just say that this is the fenced-in garden. If I want to know how much space is inside this garden, places for me to grow my crops, I can measure the space inside, and that space inside is called the area. With a three-dimensional shape, if you want to measure the space inside a three-dimensional shape, that amount is called the volume. So if I have, say, a package here and I want to know how much space is inside of this package to fill stuff in to send as a gift to my niece, I would be looking for the volume. So the space inside two-dimensional shapes is the area. The space inside three-dimensional shapes is the volume. We are going to be focusing on volume. Now, in order to find both area and volume in math, we've used something called a formula. And I like to think about formulas like a recipe. So of course, I'm going to give you an example here using my favorite dessert, and that would be brownies. So if I wanted to grab a recipe to make the best ever brownies, I'd really need to focus on two parts of this recipe. One would be the ingredients that I would need to collect to make this recipe, and the other one would be what directions would I need to follow once I gathered my ingredients. Well, obviously you collect the ingredients, you'd follow the directions, and voila, you would have your best ever brownies. The same thing kind of works with math formulas. That's why I think about them as recipes. Let's think about this for area for a minute. Area is measuring the space inside a 2D, two-dimensional shape. So my ingredients are actually going to be the two dimensions, the length and the width. And the directions that I'm going to do to find the area is I'm simply going to multiply them together. So the formula for area is simply area equals the length times the width. That's the formula. If we look at the formula or the recipe for volume, since volume is measuring the space inside a three-dimensional shape, I'm now going to have three ingredients, my three dimensions, the length, the width, and the height. And then I need to know what to do with them. The directions are going to tell me to multiply them together. So the recipe or the formula for volume is the volume equals the length times the width times the height, or volume equals length times width times height. Okay, we're going to go ahead and try some out real quick here. I can see that this question is asking me, what is the volume of this rectangular prism? And that's really all we're going to work on this year in fifth grade is finding the volume, the space inside of a rectangular prism. You can find the volume of any three-dimensional shape, whether it's a cylinder or a cone. We're going to focus on rectangular prisms. So we know we're looking for volume. So I'm going to go through my recipe book and I'm going to find the formula or the recipe for volume. Volume equals length times width times height. I'm then going to go ahead and I'm going to first gather my ingredients. So I can see from the picture here, when I go ahead, I want to find the length. Well, the length is given to me. It tells me that the length is 5 centimeters. And if you're wondering where that comes from, you can see that this is 1 centimeter, 2 centimeters, 3, 4, and 5. So when I am collecting my ingredients, I can just look right at the picture. The length is 5 centimeters. The width, it tells me, again, is 4 centimeters. So I'm gathering that ingredient, that dimension. And now the height, and I like to think about the height as how high it is or how many layers it has. You can see the height is very clearly 1 centimeter, 2 centimeters, 3 centimeters. So I've gathered my ingredients and now I simply need to know what to do with them. Well, this recipe tells me that I'm going to multiply all of them together. So to find the volume, I'm going to just go right across. I'm going to say, okay, 5 times 4, well, that's 20. And then I'm going to take that 20 and now multiply it by the 3, by the height. 20 times 3 is 60. Now, 60 is only part of my answer. You always need to label something there because I don't know 60 what. The correct label for volume in this particular example would be 60 cubic centimeters. So let me explain that for you a little bit. Here is a cubic centimeter. That means a cubic centimeter is a cube that measures 1 centimeter as a length, 1 centimeter as a width, and 1 centimeter as a height. So essentially, it's going to take 60 of these cubic centimeters to build the shape that you're looking at right here. Now, you actually know exactly how big a cubic centimeter is. If you think about those base 10 blocks that your teachers have used over the years, those little unit cubes, each of them is exactly 1 cubic centimeters. So for 1 cubic centimeter. So for this particular example, you would need to collect 60 of them to build that exact rectangular prism that you're looking at in that picture. All right, let's take a look at another example here. We know that we are looking for the volume of this rectangular prism. And I'm going to say, okay, volume, I'm going to pull out the correct formula. I'm going to pull out the correct recipe for volume. We know volume equals the length times width times height. Now, the first thing I'm going to do is I'm going to go ahead and gather my ingredients. I'm just going to do that by looking at the picture. And you can see here, we're using an entirely different unit of measurement. They did not measure the dimensions in centimeters here. Now we're in inches. So you can see the length is labeled for you, but it is 1 inch, 2 inch, 3 inches. So I'm going to collect my ingredient of length. I'm going to do the same thing for width. I'm going to see 1, 2 inches here. Again, that's labeled for you. So I'm going to collect that ingredient. And you can see the height, how high it is or how many layers. It is 3 inches high. So now that I've gathered my ingredients, it's just a matter of doing what the directions of the recipe tell me to do. That multiplication sign there tells me I'm going to multiply them together. So to find the volume, I'm going to say, okay, 3 times 2 is 6 times 3 more. Well, 6 times 3 is 18. Now, order does not matter how you order these when you're multiplying them because of the commutative property of multiplication. If you think about it, if you want to multiply 3 times 3 first, 3 times 3 is 9. And then multiply 9 times 2, that's still going to get you the same answer of 18. So however it helps you to multiply those together. Now we talked in the last example, 18 is not good enough. We need to label that. And so the correct label here would not be cubic centimeters. We're not measuring the dimensions in centimeters anymore. These dimensions were labeled in inches. So our measurement volume unit would be cubic inches. And again, cubic inches means a cube that has all dimensions of exactly 1 inch, okay? And so essentially it would take 18 of those cubic inches that you're looking at to build that exact shape in our picture. When you're measuring volume, the number is not the only thing you need to worry about. We really want to make sure we're using the correct units. And it depends on how you're measuring the dimensions. I remember dimensions are length and width and height. If you're measuring the length, the width, and the height in centimeters, then when you get your volume, you are going to want to give your volume in cubic centimeters, 3-dimensional centimeters. You can see some different ways here to say cubic centimeters. You can spell it all out. You can just abbreviate centimeters as cm. Or look at this really clever way here. You take cm for centimeters, but then you take a little exponent of a 3, and that actually stands for 3-dimensional or cubic. So that's all 3 of those are different ways to say the same thing. That would be how you would label your volume if you measured your dimension in centimeters. If you measured your dimensions for a problem in inches, then your volume would be given in cubic inches, whether you want to write it all out, you want to abbreviate inches IN, or you want to use that exponent of a 3 to represent cubic inches, whatever makes the most sense to you. You could even be measuring your dimensions in feet, which means our volume is given in how many cubic feet can fit inside that 3-dimensional shape. Now, there are going to be some examples where it doesn't tell you the unit you're measuring in. It doesn't say centimeters, inches, feet, or even miles. It doesn't say anything. In that case, your volume would simply be cubic units. And so in the next video, we're going to do just a couple more examples of finding the volume when you are not given the unit specified like centimeters or inches, so you can kind of see those cubic units used. We're going to do one more quick video with a few more examples, then it'll be your turn.